x1, x2 to xn are IID, exponential random variable, with the lambda equals 1. X bar is the average of x. First question, calculate the probability. The average is between 0.9 and 1.1. The second question, find the n so that the probability is greater than 0.95. First, let's recall that if x is exponential distribution, the expected value of x is equal to 1 over lambda. This is equal to 1 because we know the lambda is 1 and x is exponential distribution. So the variance of x is equal to 1 over lambda squared, which is also equal to 1. Now, by central limit theorem, x bar is roughly a normal distribution with some mean that's called mu lambda x bar, some variance that's called sigma x bar square. So let's first calculate the mu x bar and sigma x bar square. So mu x bar is equal to expected value of 1 over n, 1 to n xi. So this is equal to 1 over n summation 1 to n expected value of xi. So let's take a look. So when you take expected value of a constant multiply a random variable, you can move this constant outside of the expectation. And if you take expectation of the summation of xi, you can move the expectation inside of the summation. Okay? So that's why this is true, because each of the expected value of xi we just calculated is 1. So this is equal to 1. Now, sigma x bar square is equal to the variance of 1 over n summation 1 to n xi. So this is equal to, first recall, when you take the variance of the constant multiply a random variable, you can move this constant outside the variance, but you have to take the square. And if you take the variance of summation of independent random variable, you can move the variance inside of this summation. So this whole item is equal to 1 over n squared summation 1 to n, the variance of xi. And so this is equal to 1 over n squared summation 1 to n and 1, because each of the variance, it's the variance of xi is equal to 1. So this is equal to 1 over n. Let's simplify the notation a little bit. So this is mu x bar, let's call it mu bar. For the sigma x bar squared, let's call it sigma bar squared. Now, because the sigma bar squared is equal to 1 over n, so sigma bar, which is equal to sigma x bar, and is equal to 1 over square root of n. So now we have the mu bar calculated, and we have the sigma bar calculated. We are ready to calculate the probability. So the probability of 0.9 is less than equal to x bar is less than or equal to 1.1 is equal to probability 0.9 subtract mu bar divided by sigma bar less than or equal to x bar minus mu bar divided by sigma bar is less than 1.1 subtract mu bar and divided by sigma bar. Look, here we just take all the items and subtract mu bar, which is the mean of x bar, and divided by sigma bar, which is the standard deviation of x bar. So here, so this is equal to probability 0.9 subtract mu bar, we calculated, it's 1, so subtract 1. Sigma bar, we calculated, it's 1 over square root of n, so this is 1 over square root of n, that's not equal to. So x bar is a normal distribution, roughly, and with a mean mu bar, standard deviation of sigma bar. So if you take this whole item, this is a standard normal distribution. So that's called z. Z is a standard normal, and this is less than 1.1 subtract 1 divided by 1 over square root of n. So this is equal to probability negative 0.1 square root of n less than or equal to z less than or equal to 0.1 square root of n. Let's calculate this item. This is equal to probability z is less than 0.1 square root of n, subtract probability z is less than negative 0.1 square root of n. So let's take a look. So this is to calculate the probability z is between these two values. The first item calculate the probability is z is less than this. So which means this also includes the left side of negative 0.1 times square root of n. So we need to remove that because we try to calculate the probability between these two values. So we have to remove that z is on the left side of negative 0.1 square root of n. So this is equal to phi 0.1 square root of n subtract phi negative 0.1 square root of n. So phi here is the cumulative distribution function of a standard normal. So we want to further simplify this item, and we need to use this identity here. So phi of negative a is equal to 1 minus phi of a. Why is this true? This is because the density function of a standard normal distribution is symmetric. So it's plotted here. So probability of a z is a standard normal. Probability of a z is less than negative a, which is this blue region here. This is equal to phi of negative of a. So if you look at this blue region here on the right hand side, this is probability z is greater than a, and this is equal to 1 minus probability z is less than or equal to a, and this is 1 minus the phi of a. So as we can see, because the density function is symmetric, so these two blue regions are the same. So which means that the phi of negative a is equal to 1 minus phi of a. So this is true. So let's apply this formula to here. So we can change this item, simplify this item, to rewrite this item. So this is equal to phi 0.1 square root of n subtract 1 minus phi 0.1 square root of n. So this is equal to 2 phi 0.1 square root of n subtract 1. Now we calculated the probability of x bar is between 0.9 and 1.1 is 2 times phi 0.1 times square root of n subtract 1. The second question is what n should be so that this is greater than 0.95. So this has to be greater than 0.95. So this means phi 0.1 square root of n has to be greater than 0.975. So 0.1 square root of n has to be greater than phi inverse 0.975. This is equal to 1.96. So this means n has to be greater than or equal to 385. Thank you for watching.